Okay, so in the last couple of videos on the Gracity Academy YouTube channel, we've been looking at the Lambert W function, in particular how we can use it to solve equations of the form z e to the z equals c, where the solution is z equals wc. And in the last video we looked at the equation x to the power of x equals 2, and the way we solved that was by putting it into the form z e to the z equals c and then solving with the Lambert W function. We're going to use exactly the same strategy here to solve 3 to the power of x equals 2x plus 2. So let's go. So we've got 3 to the x equals 2x plus 2. And what we want, let's just remind ourselves what we actually want. We want it in the form z e to the z equals c. Okay, so first of all, let's just divide by 2, make it a nice and easy start. So that's 3 to the power of x over 2 is x plus 1. Now, we need this 3 to the power of x and the x to be on the same side. So now let's just divide by 3 to the power of x, both sides, which gives us half equals x plus 1 times 3 to the minus x. Okay, so what we need to do to get it into the form z e to the z equals c is we need this bit here and this bit here to be the same. Well, x plus 1 and minus x aren't exactly the same. So first of all, let's multiply both sides by minus 1, which gives us minus a half equals minus x minus 1, 3 to the power of minus x. So at least we have the x here and here the same. But we need this to be minus x minus 1, because this is minus x minus 1. So let's multiply both sides by 3 to the power of minus 1, and we get minus a half times 3 to the minus 1 equals minus x minus 1 times 3 to the minus x times 3 to the minus 1, which equals minus x minus 1 times 3 to the minus x minus 1. And now we have our equation almost, but not quite, in the form z e to the z. We have the z bits, but what we don't have is e. We have 3 to the power of minus x plus 1 instead of e to the power of minus x plus 1. So we just need to now sort that out. Now we're going to use the identity 3 to the power of a equals e to the power of a log 3. And if you're not convinced that that's true, let's just take logs of both sides. So log of 3 to the power of a equals log of e to the power of a log 3. And then log of 3 to the power of a is a log 3, just taking the a out. And log of e to the a log 3, again taking the a log 3 out, is a log 3 log e, and log e is 1. So we get a log 3 equals a log 3, which confirms that this identity is correct. So what we can do now, being very careful, is we can put, instead of 3 to the power of a, we can put e to the a log 3 into this equation. So let's just rewrite that equation. So we had minus a half times 3 to the minus 1, well, that's minus a sixth. So minus a sixth equals minus, it's inside the bracket, isn't it? Minus x minus 1 times 3 to the minus x minus 1. And we are now going to replace 3 to the power of a by e to the a log 3, which gives us minus 1/6 equals, brackets, minus x minus 1 times by e, we've got to be a bit careful here, to the log 3 minus x minus 1. All we've done here is we've replaced 3 to the power of minus x minus 1 by e to the power of log 3 minus x minus 1. Now, that's created a small problem in that now, if we look at this and this, they're not the same again. But it's very easy to get them the same. All we've got to do is multiply both sides by log 3. So let's do that. So we get minus log 3 over 6 equals, brackets, minus x minus 1 minus x minus 1 times log 3 e to the log 3 minus x minus 1. So we again have z e to the z, and the z now is the same, equals c. So we can now actually solve this problem directly using the Lambert W function. We can say, just like z e to the z equals c, the solution is z equals wc. Well, we know that z is here, minus x minus 1 log 3. So we know that the solution is minus x minus 1 log 3 sorry, that's inside the bracket, minus x minus 1, let's start again, sorry, minus x minus 1 log 3, which is our z, equals w of minus log 3 over 6, which is our c here. So we have, let me just rewrite that, sorry. So we have log 3 times minus x minus 1 equals w of minus log 3 over 6. Okay, so we now have our solution. And what we need to do now is we need to get x as the subject. So all we need to do is basically divide by log 3, and so that means that minus x minus 1 equals 1 over log 3 w of minus log 3 over 6, i.e. x equals minus 1 over log 3 w of minus log 3 over 6 minus 1. And that is the answer to the equation 3 to the x equals 2x plus 2. Okay, now again, it looks like it's complicated, and what we need to do now is let's just put this into real terms, because you know, what does that actually mean in terms of what x is? Well, what we need to do is we just go onto an online calculator and we look up the Lambert W function. As minus log 3 over 6 is less than 0, and I'm just going to draw the Lambert W function very briefly as it is in the simple guide to the Lambert W function. There's the red bit, and here's the blue bit here, and this here is minus 1 over e. And if this doesn't mean much to you, please go and watch our video on the simple guide to the Lambert W function. But this is w0 and this is w minus 1. This is just a very broad drawing. W of minus log 3 over 6. Now, minus log 3 over 6 is around, something around minus 0.18, something like that. So minus log 3 over 6 is somewhere around here, which means that there are going to be two solutions to the equation. So we need to find both w0 of minus log 3 over 6 and w minus 1 of minus log 3 over 6. So there will be two values of x which fit this equation. Okay, so going to an online calculator, w0 of minus log 3 over 6 is approximately minus 0.2305877, and w minus 1 of minus log 3 over 6 is approximately minus 2.6856251. Okay, so what we now need to do is, again, we need to use an online calculator, is we then need to plug these two values here, minus 0.23058 and minus 2.68, into this equation here, and that will give us the value of x. So x will be minus 1 over log 3, and again, just get that from a calculator, times w of minus log 3 over 6. Well, w0 is this one, minus 0.2305, minus 1. And then you have to plug the second value in, which is minus 2.68, and that gives you the other value of x. And the two values of x that you get out, and you can confirm this on the calculator, are x equals minus 0.79011, that comes from w0, and x equals 1.444561, and that comes from w of minus 1. Those two values, when you plug them into 3 to the power of x equals 2x plus 2, will give you, will confirm that they both